Good morning, everyone. My name is Nick. I'm the Sales and Service Delivery Manager for Drill Bits based out of Bangkok, Thailand. And just today's presentation, I'd like to go over, essentially our hybrid drill bit. We call on Baker Hughes called the Kymera Bit, and also just our portfolio of drill bits and our experiences in geothermal applications in several areas around the world. All right. So we as Baker Hughes, we've had experiences in drilling in geothermal wells. Typically, these are metamorphic rocks, volcanic rocks. I'm hearing some very similar themes here in Taiwan, where the northern part of the island is predominantly volcanics. The southern and eastern side is typically metamorphic. So we've had some, hybrid drill bit experiences in Indonesia, Japan, some PDC designs, designed specifically for volcanic drilling with the Utah Forge project in the USA, and also been involved in some quite hot and hard wells in Europe, right, in Iceland and Finland. So we have a complete portfolio covering, from PDCs all the way to rock bits and somewhere in between the hybrid drill bits, right? Hopefully, one key takeaway I want you guys to take from my presentation is that bit selection is critical for any drilling project, right? So it comes down to really identifying what your geological hazards are from a rock strength formation, what type of rocks you're drilling, how homogeneous or how heterogeneous your rock formations are in the wells that you plan to drill. And essentially, based on this information, you can actually cater the drill bit design, whether it's a PDC bit, a hybrid drill bit, or even a rock bit, to address those solutions, those issues. So, as you know, generally speaking, even in oil and gas and geothermals, wells are getting deeper, they're getting harder, you're drilling in tougher rocks. And this is where the hybrid drill bit, the Kymera hybrid drill bit, could potentially be a potential solution. So this technology is, I would say, quite mature now. It's over a decade old. We started the first generation commercialized back in around 2012. And essentially, as of today, we are on the 6th generation of the Kymera hybrid drill bit, where essentially you look at multiple factors in the bit design and material selection to try to improve the rock bit. So here on my next slide is things that we would typically focus, when we design a drill bit is, how do we lay out the cutters to address the challenges in the application? One thing that we did find with previous generation Kymeras was that a weak point would be the outer area of the drill bit, so the bits could come out under gauge. That's something that's been addressed. We looked at materials in terms of the carbide selections, the shapes, and also the cutters as well, right? The diamond part of the drill bit. And now we also look at creating digital twins of the bit designs, where we can actually model them in an internal software, right? So that we can kind of like test the concept before we actually manufacture the drill bit. So some key things, like I mentioned earlier, from jumping from the 5th generation to the 6th generation, is that we further optimize the cutter, the PDC cutting layout of the drill bit here. Looking at, manufacturing, be able to get more blades to center. This is quite important in hard rock drilling. Maximizing the shoulder coverage with the feature we call the shadow cut to ensure that, the bits stay engaged. Have a higher probability to stay engaged when you drill in these tougher formations. And we also created a kind of like a cone guard mechanism design, right? Where essentially if you do have a seal failure, you reduce the risk of actually losing any cones downhole. So at least if you do have a cone failure, when you trip the bit out, the cones have a higher chance of actually still being part of the drill bit as well. So yeah, this is just a more, I guess, focused feature of the cone guard here, where essentially, as you can see, if there's any failure in the seals of the cones, mechanically, it'll be still part of the bit. Oops, sorry. And here is just an example of like our digital twin software, where we can, design the drill bit, a concept, test it out, see if it's addressing the issues that we're seeing, whether or not we need to tweak the design, One thing we can do internally is that we can make the hybrid drill bits act more like a PDC. So you can potentially drill a little bit faster, or act more like a rock bit, right? A tricone bit, whether you're having more challenging or harder formations. So it's, again, it comes back to identifying the issues that you're planning to drill and then optimizing the bit selection and the design. So this is a typical process we would follow in terms of this, right? We would try to identify the challenges, align the challenges to the bit design, run the simulation to see if our concept actually will work, and then verify it in the field. And then from there, we would then take all that data back and look back at these drill bit design to see, okay, is there anything else we can do better from this design concept? All right. Any questions before I move on to some of the case histories? All right. This is typically how we would nomenclatureize our Kymera hybrid drill bits. So you can see number 6 is the 6th generation. We have identifiers to confirm whether our seals in the cones are elastomers or metal. And then you obviously have the cutter size, blade counts, and then the cone counts as well. All right. So one case history is from Utah Forge. This is actually a PDC bit design. As I mentioned earlier, Baker Hughes, we designed I believe it was a 7-bladed and an 8-bladed bit design optimized for the granite drilling in Utah Forge, where essentially this was run on all the 4 wells in that project. And as you can see, the wells, the first well drilled is the red line, and with each iteration of the bit design and also other improvements in the project, essentially they were able to reduce the on-bottom drilling time significantly, right? And this is like a continuous step process involved. So, you have to be very dynamic in this industry, learn, and apply those learnings. I think that will be the key takeaway here. Next, I'm going to move over to somewhere closer to home here in Taiwan, Indonesia, where we have, I guess, 2 key applications in Indonesia where we drill through volcanic rocks in South Sumatra, and we have some metamorphic applications in North Sumatra. So one of the applications in Indonesia, we're drilling to breccia, tuff, and andesite, right? This stuff can be quite nasty. You can really break PDC bits, roller cones, so we drill very slow through them. The unconfined compressive strengths can be upwards of 25,000 PSI. The rocks are coarse and they're quite cemented, making them quite abrasive, hard. And lastly, it's also interbedded, right? This is not good for a drill bit. Typically, the ideal environments is homogeneous formations, keeps things steady. But whenever you go from soft to hard, or from hard to even harder rock, that's where you can get really some real challenges and cause some issues. So the chimeras typically would work by pre-fracturing the formation, and then the PDC cutters would then sweep in. Yeah. So then we would model this, adjust the percentage of how much the rocks are cut by the roller cone part versus the PDC part. And based on this, we saw significant improvements in both durability and our rate of penetrations, right, in Indonesia here. So we essentially, in the 17.5-inch section, we saw about 20% improvement in distances drilled and a 74% improvement in rate of penetration versus your conventional rock bits drilled. In the 12.25-inch section, we were able to double the time spent on bottom, 100% improvement in the distance drilled, and then about a 45% increase in rate of penetration rate versus conventional roller cone bits. All right. Another application in Indonesia is metamorphic rock. So this will be applicable to, from what I understand, the southern part of Taiwan here. So this is in North Sumatra. But the top layer is interlaid with quartzite, so it's a little bit mix of volcanics and metamorphics in the top hole section. But as you get deeper into the well, you're actually drilling into some quartzites and phyllites, right? This can be very abrasive and very hard. So here, the Kymera and the 17 section, we're essentially able to drill about 260% faster than conventional PDCs that were run in this application, and just slightly faster than the PDC bits, essentially. But essentially, you're getting more efficiencies because you're actually spending more time in the hole, less time tripping, and also less risk of the bits coming out under gauge, right? So you have better borehole quality. For the 12.25, which drilled into the quartzites and felsic intrusions here, the drill bits here, we saw about 69% farther distances and 30% faster ROPs versus the conventional PDC bits that they were historically running in this area. Right. Moving on to Japan. So we had a very successful campaign in Hokkaido several years ago. I was actually personally involved in this project and the selection of these drill bits. So the challenge here, we were drilling through some igneous and volcanic rocks in Niseko area, Hokkaido, Japan. Not a very complicated well profile, just J-shaped, about 2,000 meters MD. The key thing here was that they had a very narrow window of drilling, right? Because they had to drill only during the spring and summer and basically demob before winter time. And this well was happening during COVID, so that added extra complications. So historically, they would run PDC bits to no success. They would bring these out. Roller cone bits would do the job, but at a very low penetration rate. And based on COVID-19, this operator essentially reduced their well count from 2 wells to 1, right? Because they didn't think they were able to be able to catch up the time period. So I worked with this operator to essentially select the drill bits involved. We looked at design concepts. We did some laboratory testing as well, just to ensure that what we were selecting was correct. Just generally speaking, the bit aggressiveness of the hybrid drill bits, unsurprisingly, is somewhere between a roller cone bit and a PDC bit, right? And this can affect, your rate of MSE. So typically, your PDC bits, your roller cone bits are typically more efficient, but slightly slower. PDC bits can require a little bit more energy to break rock, but you can drill faster. And it's just trying to find that sweet spot in between. Whether that's applicable to the application or not really requires us to actually do a study and propose a design as well. So in our lab testing, we get some rocks set up in our drill lab in the Woodlands, Texas, actually putting different types of rock strengths, combining them, and essentially just running the hybrid bits versus PDC bits just to see how they respond, right? When I say respond is what is the torque signature, what are the ROP signatures here. And the key takeaway I want you to get from this slide is that typically you would see smoother torque responses with hybrid drill bits. And that's very good for drilling because that essentially means that the energy you're putting into the drill string is actually, most of that is actually being spent breaking up the rock. So based on this Japan project, I actually leveraged a lot of the historical data run in Indonesia for the bit selection here. We did tweak the design slightly on some of them. And essentially, we came up with this 17.5-inch hybrid design here. This, you could probably say, is a more aggressive Kymera design, meaning that it will probably act more like a PDC, given that the topple formation was slightly softer. And then as we went deeper into the well, we went into more conservative designs, right? Making the Kymera act more like a rock bit, but still having some of that PDC potential to catch that ROP where needed as well. The wells were relatively hot, so we leveraged the metal face seal technology that we have to ensure that we reduce the risk of seal failures. And it was very good to see that once we completed the project, the operator was able to get their second well back online, and essentially we doubled the ROP in all of these sections, resulting in about savings of about $2 million here. And yeah, These are the bit bells from that Japan project. So yeah, that is it for my presentation. I'm hoping that we can work more closely in Taiwan, select the correct bits for the right applications here, and then yeah, thank you. Any questions?
Thank you so much, Nick, for this comprehensive overview of the characteristics of the Kymera drill bit. So we still have 4 more minutes. Any questions are welcome.
Yes. So, well, actually, I think it's
Okay.
So you say that when you like the geologic setting and the boundary volcanics seems like somewhat similar to what Sumatra has.
Yes, that's correct.
Yeah. So like when you use a Kymera bit, you said that you can like adjust it or like choose the select the
Characteristics. Yeah. Yes, that's correct.
So when you use the Sumatra, I mean when you drill in the Sumatra formations, do you use a bit that's more similar to like PVC or a triangle?
So for the 17.5 inch, it's more of a PDC type bits because the formations still don't firm up that much. But as we go deeper, the designs become more, lack of a better word, conservative, right? So we have to prioritize durability more than RP potential. The thing is with drill bit design, there's always a little bit of compromise, right? If you want to go fast, sometimes you can't go very far, if that makes sense. Yeah. So it just really depends. And I think if we look at the formations in Taiwan, we would definitely need to sit down and see how different or how similar it is to Sumatra, for example, in terms of rock strength, how interbedded or homogeneous the formation is as well, because that can affect how we select the design to be run. I'm hoping that answers your question.
Yeah. So like for basically when you use a Kymera bit, you have to have the requirements for using a bit, right? I mean, you have to have the right equipment and tools to use those bits instead of like because using a tricone is easier.
Not always necessarily, but that is something we can always work with, right? To determine that the drill string, for example, and the drive systems used and the rig is able to at least deliver enough power to ensure that we are maximizing the drill bit. So I guess just generally speaking, for example, when you run a Kymera bit and you compare it to a rock, this is just a general simplification from my experience anyway. You can run maybe between 60 to 70% weight and bit requirement for a rock bit at the same size, right? But then versus the PDC bit, you'll definitely need less weight and bit to achieve similar ROPs. So you're right. It is a holistic approach to it, right? It's not just selecting the drill bit and then everything will go well together. You have to look at the full picture.
Okay, we can take one more question.
Thank you very much for the presentation. I have like a small question.
Yes.
So the bit life
Yes.
of the Kymera.
Yes.
So the PDC basically when the RP drops then we pull out, right?
Mhm.
For the tricones, more like revolution count.
Yes.
With the Kymera, which one do you need to take in consideration?
Both. So you'll need to look at your seal life. So for example, in Indonesia, we actually have a reliability curve for the Sumatra fields. We know that once you hit a certain revolution, you could potentially trip the Kymera out. Secondly, you also need to look at the response downhole, right? What changes you're seeing with torque. So for example, if you're drilling a Kymera bit, you're approaching your hours that you set a baseline, and let's say you see a sudden increase in torque and an increase in ROP, that could potentially be a signal that your cones are locked and the PDC part is doing the cutting. And that's why you'll see a spike in ROP and torque. Does that make sense?
So typically, right?
Yes.
Tricone bit lasts for like 3-4 days.
Mm-hmm.
With a Kymera, that's even pushed like more.
More, potentially more.
Potentially
Yes,
more.
yeah, potentially more.
But-
It'll vary about application to
But
application.
with the anti-drop cone system, you can actually drill until you get the anomaly, or
Yes, you can
there
typically drill until you get that anomaly, but then once you see the anomaly, then I would recommend to trip right away because once the cutting, I guess there's two ways that you can lose a cone, right? One is from hours drilled, and then the other one is that your cutting structure just fails, right? You actually eat into the body of the drill bit. So yeah, typically you see an anomaly, it's typically time to trip.
Thank you.